Well, welcome back. We're going to continue our little discussion on how to use the product and quotient rule and find the derivatives. What we have here is I have another example. What you see is we have a function over another function, and we also have this function being multiplied this function. Now, what you could use is in order to solve this, you could use the product rule and the quotient rule and whatnot. However, what I would suggest is whenever you're given something that can be simplified, use algebra. Algebra is your friend. All right. If used correctly. Uh-huh. All right. So, we'll talk there. So we're going to simplify this first before we do any of our other expressions. So right here, I'm going to distribute this x to here and to here using my algebra skills. Yeah, that do pay the bills. All right. And we're going to do this. Now, once we have this right here, we're going to now take and find our derivative. And now, yes, I'm going to use the quotient rule. The quotient rule, once again, states that we're going to take the derivative. So whenever we have h over f and g, so two functions, to find the derivative, we're going to take the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. All right, so we're going to take the derivative of the top, which will be 3x squared plus 1, times the bottom, which is x plus 3, minus the derivative of the bottom, which is 1, times the top, which is x cubed plus x, all over this bottom squared. So we have x plus 3, that quantity squared. I'm just going to simplify this a little bit because I can. All right, this is two binomials, so it shouldn't be that difficult. We're going to have 3x to the third, all right, plus x plus 9x squared plus 3. I'm going to distribute this negative through negative x cubed minus x, and the bottom will just leave the way it is because I don't think we really want to do anything with that one right now. All right, so what we have right here, simplifying a little bit farther. Any x cubes? Yes, we do. We have 2x cubes left over. Any x squareds? Yes, we have actually 9x squareds. That right there. We have these and this will cancel out, and we're left with plus 3, bing, and all of the over x plus 3, that quantity squared. And that is our derivative. I'm sorry that's on an angle, but that's just how I'm writing right now. Okay, so that's using the quotient rule. Key thing to remember when you start with your derivative, if you can simplify, algebra is your friend, do so you can make it easier function to find the derivative of. Well, let's try one more, or actually two more. Here we go. Right here, we could use the product rule. Well, once again, if you stay by my rule, I would try to avoid using the product rule here. Okay, if you can, we're going to have this is x to the 1/3 power. All right, this is going to be times x to the 1/2 power, and this is going to just be plus 3. What I'm going to do before we do anything, I'm going to simplify this puppy. We're going to take this and distribute it through. I'm going to have x to the 1/3 times x to the 1/2. We're going to add those together, plus 3x to the 1/3. From here, I'm going to add these two exponents. All right, that's going to turn into 2/6. This is going to turn into 3/6. Add together, we have 5/6 is going to be my answer. And then we have plus 3x to the 1/3 power. Okay, so from here, we are now ready to take our derivative once we simplify this. We have a bunch of power functions, which makes it a lot easier. So we're going to do a little power rule. So what we're going to do is we're going to take the derivative of this function, which should be 5/6 x, subtract 1, should be negative 1/6. We're going to then take this, which you're going to put to 3. 3 times 1/3 is 1. X subtract 2 is negative 2/3. And that would be our answer. We can simplify this and get rid of these, put in the bottom. So we have 5/6, so x to the 1/6, plus 1 over x to the 2/3 power. Bada bing, bada la boom. And that is our answer. All right. Once again, algebra is your friend. Use it and use it wisely and do it correctly. I think we have time for one more. So let's check out this last one right here. Okay, now this is a kind of a popular one. See in a lot of textbooks and whatnot. You see f of x equals c squared minus x squared over c squared plus x squared. C is a constant. Many students think, well, what is c? C is a constant. What does that mean? That means c is a number. Okay, c is a value. It's a number. It's being squared. So it's not a variable. Okay, it is a constant. So here everything is simplified. We have a function over another function. We're going to use the quotient rule. All right, quotient rule to find this derivative. Okay, so we're going to find this derivative. We're going to find f prime. And so we're going to take the derivative of the top, numerator, and that's going to equal, since c squared is a constant, that's going to turn to 0. Rather than take the derivative of negative x squared, which would be negative 2x, times the bottom, which would be c squared plus x squared, minus now the derivative of the bottom. Once again, 0. Derivative of x squared is 2x. All right, times the top, which is c squared minus x squared, all over the quantity c squared plus x squared squared. We can simplify this a little bit. All right, we'll do that. Negative 2x c squared minus 2x to the third. All right, minus 2x c squared plus 2x cubed, and all of that over c squared plus x squared, the quantity squared. All right, and that's our derivative. Let's go a little bit farther since we made it all the way through. Can we combine anything? We have, it appears we have negative 4xc squared. These two will appear to cancel. Oh, that's sweet. And we have our final answer, c squared plus x squared. And there it is. There she is. Right there. Once again, on an angle. I love writing on an angle. But that's what we have for our solution. Negative 4xc squared over c squared plus x squared squared. All right. So from here, we use the quotient rule to get our derivative unsimplified. Simplified using algebra, that means algebra in Spanish, and we get our answer simplified here. All right. So give you another 3 examples of how to use the product rule and quotient rule in solving different various derivative problems. Hope this helps you out. If you have any other questions, a lot of other good tutorials out on YouTube and whatnot. And hopefully this helped you out. So good luck and God bless in the rest of your problems.